in charge of is complex systems engineering. Most of us will recognize that we have various systems in our lives, and what we're trying to do within this theme is understand how can we take small systems which we know work and scale that to large systems. Things like NHS systems, Mars rover systems. These things are extraordinarily difficult. In people's everyday lives, if you call NHS Direct, again, it's a big system which is spread across the country. How can we make sure that works in the way that a small system is much easier to make work?
People have used computers for a long time to try and solve the kind of problems that are too difficult for people to solve that machines are very good at. Almost every business has some kind of problem that they want to solve, that if they could do it in a smarter way could really benefit both the economy and society. So for example, if we just take vehicle routing from a company's perspective, if they can schedule their vehicles in a smarter way, they can use fewer vehicles, that means they use less fuel, that means they emit less carbon dioxide, and that's obviously much better for society. But I think the thing that sets our research apart from that is the systems that we're developing are able to continuously learn over time. So we're trying to develop systems that can do exactly this. They can learn from experience, that every time they solve a problem, they get a little bit better at solving the problems. But we also want to have the system to be able to adapt so that it can solve new unseen problems in the future.
I'm working on the CLOPIMA project, which stands for Cloud Perception and Manipulation. Well, CLOPIMA, in a sense, aims to advance the state-of-the-art in autonomous perception and manipulation of textile fabrics and garments. So, well, in this project, the task of the robot is to select and classify garments from a pile of laundry. We plan to achieve this by integrating perception, action, learning, and reasoning as an overall robotic framework. Well, this research can be applied for housekeeping, for garment manufacturing as well. Who wouldn't love a robot doing your own clothes and folding and all this laundry? At the moment, we have a PhD student who is SICSA funded and is taking advantage of the facilities that CLOPIMA, the robotic facilities that CLOPIMA provides. And his research will serve as the basis for the selection of optimal grasping points and also for folding, sorting procedures.
SICSA is very good. It allows us to work with other universities in Scotland. Scotland is very unique in that it has, for a small country, an enormous amount of scientific talent at its disposal in the various universities around Scotland. However, in the day-to-day lives, there's a natural tendency just to get on in our own university and talk to people there. What SICSA encourages and allows us to do is to actually work with other people. So, for example, various different projects happen with my university in Edinburgh, St Andrews and Heriot Watt work together, and there's all sorts of kind of interactions, and this builds a greater fusion that we'd have otherwise.